Lauryl alcohol is a non-electrolyte, meaning it does not dissociate in solution. Obtained from coconut oil is used to make detergents. A solution of 9 grams of lauryl alcohol in 0.2 kilograms of benzene freezes at 4.2 degrees C. What's the approximate molecular weight? Well, we're given mass, we're given kilograms, we're given freezing point, so we should know to use that our delta TF equals our negative I times our KF, our constant for benzene, the freezing point depression, and times molality. So we know a few things already. We know I equals 1, and that's because we have a non-electrolyte in solution, so 1 lauryl alcohol in solution. KF, if this was an exam question, I would give you KF, or for this question, you'd have to look it up. So the KF for benzene is 5.12 degrees Celsius per molal. And then the last thing we need to find is our change in freezing point. So the normal freezing point of benzene is 5.5 degrees Celsius. We observe 4.2 degrees C minus 5.5 degrees C for a change of negative 1.3 degrees Celsius. So let's plug in what we have into the equation. So negative 1.3 degrees Celsius equals a negative 1 times 5.12 degrees Celsius per molal times our unknown. We don't know the molality of this solution. So multiply those two together, and we're going to end up dividing by negative 5.12 degrees C per molal. And we'll divide this side by a negative 5.12 degrees C per molal. So that cancels, degrees C cancel, and we're left with a molality of 0.2539. But, we're not done there. We need to know what is the approximate molecular weight of lauryl alcohol. So we know, hopefully we know, that molality equals moles of solute over kilograms of solvent. So we know molality equals moles of solute over kilograms of solvent, and we know in this reaction, or in this situation, our molality equals 0.2539. We don't know how many moles we have of lauryl alcohol in solution, but we do know we have 0.2 kilograms of solvent. So multiply by 0.2, and we should find that we have approximately 0.05, we'll say 0.8 moles of lauryl alcohol in solution. And are we done there? No, because finally we need molecular weight. And so the last equation we need to know, moles equals grams over molecular weight. So yeah, now we know we have this many moles, and we have 9 grams in solution. We don't know the molecular weight in grams per mole. So multiply, and then we're going to end up dividing 9 by 0.0508 moles to find that the molecular weight of lauryl alcohol is approximately 177 grams per mole. And be careful, your values might be a little bit different. Mastering chemistry randomizes some of the variables, so you might not have exactly 9 grams of lauryl alcohol. You might have a different temperature change, but the process, the step-by-step process, is going to be the same. Number 1, we had to plug into our equation. Number 2, we had to find, after we found molality, we had to find how many moles. And then number 3, once we found the moles, we had to find, okay, what was the molecular weight of lauryl alcohol?